Here I am going to explain how to find the roots of the equation by using bisection method. Usually bisection method known as Bolzano method, approximation method and interval halving method or interval dividing method, etc. So, let us see the theorem which names intermediate value theorem, that is, consider the continuous function f which is continuous from the points a comma b are of denoted in the x axis. So, let the function values of f of a and f of b are of opposite signs, then the equation f of x equal to 0 will have 0 at least one real root between a points a and b. Now, I am explaining this theorem in geometrical form, and here a comma f of a is plotted here and b comma f of b is plotted here, and the continuous function is f of x, and we have to find the root of the function f of x such that f of x equal to 0. So, the point f of x equal to 0 is lies in the x axis. So, we have to find or we have to express the value some x comma f of x equal to 0 is here. So, we are going to find the point C is here. So, now we have to follow the algorithm, that is, determine the interval in which a root of the equation f of x equal to 0 lies between, and next the points a and b are of the 2 points, and we have to find the function values of f of a and f of b is here. Here f of a is negative and f of b is positive. So, there are opposite in signs, and by the theorem there is a point which lies between a comma b in such a way that f of x equal to 0. So, how to calculate the point x1? So, x1 is nothing but the midpoint of a and b. Midpoint is nothing but a plus b divided by 2. So, now again we have to calculate the function value of x1, that is f of x1, which is also negative. So, by the theorem f of x1 and f of b are of opposite in signs. So, there are the root lies between x1 and b. Yes, x1 and b, there is a root lies between in them, and again the interval is dividing into too small. So, here the root lies between x1 and b is x2. So, the midpoint is x2, and again we have to calculate the function value of x2 here. So, x2 f of x2 is positive. So, here f of x1 is negative and f of x2 is positive and f of b is positive. Here f of x1 and f of x2 are in opposite signs. So, the root lies between x1 and x2. So, again the interval is dividing into too small. So, here the point x3 is here and x3 is nothing but the midpoint of x1 and x2. So, likewise we have to proceed this process until we get the point x1 or x2 or x3 which satisfies the equation f of x is equal to 0. So, here I am going to explain this example. X cube minus 4x minus 9 equal to 0 is an equation, and here we have to find the root lies between the interval. So, f of 0 is minus 9 which is negative, and f of 1 is minus 12 which is also negative, and f of 2 which is minus 9 which is also negative, and f of 3 is equal to 6 which is positive. So, the root lies between the opposite signs 2 and 3. So, we are here we are gonna find the roots or xi's in the first column and the function values of xi's in the second column. So, the root lies between 2 and 3. So, the midpoint is 2.5. So, 2.5 the function value is minus 3.375. So, likewise we have to proceed this above the process and repeat the same until we get the root which satisfies the equation f of x equal to 0. So, the approximate value of a root of the given equation is 2.7065. I have to correct this decimal into 4 decimal places. Here the convergence of the root is very slow because our iteration is too big, because 2.5, 2.75, 2.625, next the iteration is 2.71875 and the last iteration is 2.7105. So, when will we have to terminate this process is until the xi's are approximately equal. For example, 2.71875 is equal to 2.710. So, then only we have to terminate this process to get the roots of the given equations. Thank you.